Okay, time to get started. So welcome everybody to Math 216. The first thing I'll mention is that I am currently video recording this lecture. This is something I have to start off with because I think it's a law. I think it's a state law that if someone's being recorded, they have to let them know you can't secretly record people, right? So anyway, I am recording. What it's recording is my laptop screen, which should be identical to what's on the screen that you're looking at, and it's also recording audio. Now, most of y'all are way too far away for your voices to be recorded, so I think it's pretty moot, academic. I think my voice is going to be overwhelmingly the most recorded thing on the audio track. But if you're asking a question or something, you might get picked up on the track. And as I think y'all probably know from an email I sent out earlier, I'm going to take these recordings that I'm making and I'm going to put them up on my YouTube channel just as a convenient way to give y'all access to these recordings. So anything that we talk about in class, I want y'all to be able to conveniently go and re-listen to that again. So now, that said, while I am recording today, this is the only day that I'm going to record for about the first half or so of the class. For the first half or so of the class, again, from an earlier email from me, we're doing a kind of a flip structure. So you'll already have recordings. Those recordings that I made a couple of summers ago are already posted on that YouTube channel in one of the playlists. So since you already have the recordings of the content, I feel like you don't need the live recordings on those days. But today we're talking about, how to do well in this course, kind of procedural stuff, and those are not pre-recorded. So today only, then a whole long no recordings in class because of the pre-lectures, and then starting in, mid-October or something, we'll switch back over to recording live lectures again. Okay, all right. So let's get into my notes. If you think you might be a math major or a minor, come talk to me as soon as possible after class is over. Very important. This is not the right class for you. Probably, maybe, but very likely not. So anyway, we need to get that straightened out. So possible math minor, possible math major, come talk to me. Okay. The website. So here's a link to sort of all of my class websites. I'm pretty sure I emailed y'all this. Quick side note. If you have not been getting emails from me, come talk to me. We need to figure out why that is. I'll be using email to communicate important information throughout this term. So if you just joined the class, for example, what I need to do then is identify who you are so I can send you past emails that I have already sent to the class roster and send those to you. Okay. All right. So here's your first homework assignment is to pretty much read the web page. So specifically, there's the main page. I want you to read all of that. In fact, let me come over here and show you. See, I think this is the one. Here we go. There. So this is the web page. Read all of this main page. There's a lot of suggestions there, discussions, policies, links, useful information. Notice the syllabus is linked here from the main page. The lecture schedule showing what we're doing when. The recording schedule that breaks down all of the pre-lectures into sort of what we're covering on each given day as indicated by the lecture schedule. You need all of these things. These are all really important. Okay. And much other stuff. Links to my YouTube channel right here for how to get all these recordings that we're talking about. Okay. Let's see here. Okay, so read all the main page. Then there's 5 links in the course information section that direct you, that say, read all this material. And those you'll see up here, right there. Right, 5 links there. The first 3 are sort of procedural about course policies, general comments about how to do well in the class, and the kinds of things that I would assume and that you should realize that I will assume, that sort of thing. Policies about how exams are going to work, homework procedures, this kind of thing. The grading, of course, superseded by that new one over there. Proofs. So this link here gives some discussions about what is a proof, what is not a proof, We will be doing a few proofs in this class, not a whole lot, nowhere near as much as Math 221, for example, but more than Math 212 by quite a bit. So linear algebra, as it turns out, is just very well suited for communicating ideas in terms of proof. So we have to do at least a little bit of that. So you need to know the basics of what is a proof and what is not a proof. This gives a discussion of that. We'll also, talk about that as the term goes on a little bit. This is, of course, an important link. I'm going to use a new grading system this term. It is described in, I think, complete detail at that link. Let me go ahead and click on that. I think this is going to be a really good system. I think students are going to like it. It's great in terms of transparency because here's the formula, right? And likewise in terms of predictability, and if you want to know where you stand in the class in a meaningful way. Right? We can quantify exactly what we mean by saying, currently, with these details, here's what you currently have. Under the old system, under the system that applied to your Math 212 experience, none of that was really possible because of the block structure. So anyway, make sure to read all of this. If you have any questions, you can come talk to me. I think everything you should need to know. So I'll comment about this while I'm here. Note the weights of the midterms, not exactly constant. I have the weights of the midterms sort of increasing. The idea then is to give you a little bit more leeway. I mean, instead of having these 20, 20, 20, 40 or something like that, putting a little bit of a slope on it, right? If you mess up on exam 1 and you turn yourself around, cool. It didn't count as much. These count for more. That kind of thing, right? So, plus having increasing weights gives a numerical, I'm going to say, advantage to students that are on an incline as opposed to a decline in performance in the class. I think that's reasonable, right? So anyway, pay careful note to that, and read through these notes, the little scenarios, 3 little scenarios that I explained down here. I think y'all will find this appealing. Okay, enough of that. All right, back to these notes. So you want to read all of those, read all the main page, read all of those 5 links. Take me seriously, right? When I say this is going to be a hard class, it is. Not true in all classes. They told me that in high school. I was like, this is a really hard class. I'm thinking, come on, that's big talk. It's, that wasn't that bad. But anyway. Also click around, right? Check out what's at the links that are on these pages. You don't have to read all of what's on all of the links from all of these pages, right? It's too much. But just, it's a good idea to kind of know what's out there and, what I'm making available to you all. And these documents that we talked about, the syllabus, the lecture schedule, the recording schedule as well, I think it'd be a good idea to print those out and, tack them up on the wall next to your desk in your dorm room or whatever is the modern version of that we used to do when I was in college. Okay. I want to say a few words about resources you have available. This is cheesy, and I apologize. But I think it's important to list yourself as your own primary resource. The point there is this is just about sort of like responsibility and initiative, right? You have to make sure that you push yourself to learn the material to the appropriate level, right? So you can't expect that I or the TAs will be following you around and making sure to push you as needed. We'll do that when the opportunities present, but you can't assume that that's going to happen, right? So by and large, you've got to be your own engine in this class. The book, it's not bad. I don't hate the book. I don't love the book. There's a couple things about the book that are really problematic, and I will complain about those when we get to them, right? Anyway, altogether, though, it's a good book, and I like it, and I think you'll find it to be a good resource, so I want you to take advantage of that and actually make use of it. Likewise, now there's my lecture notes. Here are, y'all have already seen It's the first pre-lectures, and so you've kind of seen how my lectures are going to go, how the pre-lectures go, and of course the live lectures will be out of the same notes. So I think these are good. I like them, but of course I'm biased. So these written resources, I encourage you to read them before class. I think it's a really good idea to kind of know, what you're about to see, what's about to happen, what are the ideas that are going to be discussed. If you already kind of know what's going on, then you'll get more out of the lecture and the pre-lecture. And then I think it's a good idea to read them again after class, or after you watch the pre-lecture, and maybe after class. Right? The more sort of passes through the materials, kind of like layers of paint when you paint something. Multiple layers, you get a more robust job. Okay. By the way, another reason to read those resources: we will not have time to do it all in class. I'm going to use class time the way that I think is going to be the most effective. I'm going to be explaining the ideas that I think that you can get the most out of me helping you with, the hardest ideas to really digest. So I'll be skipping examples from the book. I will sometimes skip over examples in my own notes. These are all just kind of different resources for you, to have to work with. So they don't necessarily have to all equal to each other. So just in a Venn diagram, there's the book. There's my lecture notes. There's class. You're responsible for all of it. Yeah. Okay. All right. Okay, let's see here. Now, you'll notice I have myself listed as a resource here, and likewise the TAs. Each of you will have a TA that you meet with in discussion sections on Thursday or Friday, right, depending on which one you signed up for. And we hope we can be good resources for you, right? But do note, cannot emphasize this enough, number 3 on the list here, right? So anyway, that said, I hope we can be a good resource to you. Obviously, you have to come to class in order for me to be able to be a good resource for you. By the way, since I started doing video in my classes, let me rephrase that. When I first started doing video in my classes, my class attendance tanked to like 25%. Yeah, you can probably guess why. Right? Students were thinking, oh gosh, it's all a long way over there to the classroom. I'll watch the video later. Right? And 2 things. First of all, I noticed that a lot of students did not watch the videos later. A lot of students just ended up, kind of just getting way, way, way behind in the class. And the class performed poorly that term. So that was a learning experience for me and for them. But more so for me. And so since then, I've made class attendance required and part of the course grade. And then my class attendance jumped back up to perfectly normal, good again. Anyway, you do have to come to class. It is part of your grade. Plus, as I comment every year at this point of the intro, this is not the University of Phoenix. And so, we need to be in the same room. That's why we're here. Okay. Last resource I want to list, classmates. I encourage you to work on homework together in groups. I did a lot of that when I was in college. I think it's a really useful tool, right? Likewise, in studying for the exam, I think studying in a group is a great thing. Now, I think both of these should be supplemental to what I hope, of course, should be everyone's cornerstone study technique, which is just alone with the material, alone with the book, alone with the notes, alone with the videos, whatever. You got to be your own cornerstone study resource, but working in groups can be a really great supplement. So I hope you all will think about doing that as well. Okay. By the way, let me take a pause. I talk a lot. So does anybody have any questions so far? Is everybody good so far? Okay. All right. Okay, moving along. Let's talk about expectations. A lot of high school math classes are, memorize certain facts, know how to execute certain algorithms. It's very sort of, I'm going to say memorize and regurgitate kind of. My high school had a lot of that going on. So if you know how to do all the homework, then you de facto know how to do the exam because the exam's a subset of the homework, that kind of thing. So that's something that you should be able to do, yes, but that's really only step one. That's certainly not sufficient to do well in this class, at a school like Duke. So we expect more. We expect, for example, that you'll understand the ideas, right? I mean, this is a big deal, understanding the ideas. We test whether you understand the ideas, among other methods, by asking you questions that we have not previously showed you how to do. And the way that you're going to answer these questions on an exam, unfamiliar situation, either an application you haven't seen before or a type of equation that we haven't exactly addressed before, is say, well, look, this is similar, got a lot of the same kind of structural characteristics as this example we did in class. It's different in certain ways. So I'm going to take the solution that we did in class to the example we saw in class, and I'm going to adapt it appropriately. And exactly how much you have to adapt, well, depends on the situation. We talk about that a lot, of course, in the pre-lecture about the checkerboard problem, right? The many different variations of, checkerboard type questions, some of which were pretty much exactly the same as the content that we showed you, all the way down to the end where the questions are clearly related but very different, right? Okay. So anyway, be prepared for that kind of thing. This is not done in all high school math classes. Probably, I'd be pretty surprised if you got through Math 212 without having to do a fair amount of this, right? But there will probably be a little bit more of it, even so, in Math 216. Okay, how many of y'all know what Wolfram Alpha is? Show hands. Okay, most, not all. I punched this up right before class started. Notice what I typed in here. Let's see if I can make this bigger. There we go. I didn't even type it down in code. I just, almost in speaking language, integral of the reciprocal of 1 plus sine x, and boom, it does the work for us, right? So here's what this means. And by the way, this is just one of many, many things that Wolfram Alpha can do extremely well and for free. Wolfram Alpha is pretty awesome, and I think there's a pay version of it or whatever. But this is all free. So this brings me to a good explanation of why it is that it's simply not good enough to just memorize algorithms. One way to say it is we don't need you for that, right? We have Wolfram Alpha for that. So think about a future employer, a future graduate school admissions committee, and they're looking at your mathematical knowledge, right? And if your ability to do math is just stuff that Wolfram Alpha can already do, right? Then what do you really offer there? What does it mean that you know some math? You know how to do stuff that is freely doable on the internet for free, more reliably, more quickly than you can do it, right? So anyway, I think this is it's a little bit of it's a rough observation to make, right? But I think this does communicate the point of, this is why we need you to know more than algorithms, right? We need you to understand why ideas work. These kinds of understanding, being able to apply mathematical ideas to circumstances you have not seen before. Wolfram Alpha cannot do that. And I don't really think they're particularly close on being able to get stuff like that to happen. So understanding and being able to apply your understanding creatively. These are the kinds of things that make you something that give you something to offer when you're going for your next thing, whatever that might happen to be. Okay. All right. Related topic. Students very often say, well, just show us the math that we need to be able to do. Right? Well, that's constantly changing. I don't know what that's going to be for y'all. Right? I mean, you're not in industry right now. Right? You're not currently working on an exact specific problem that you need to deal with. Y'all are going to be in industry at least a couple, 3 years from now, and you'll probably still be in industry or academia or whatever you end up being in 20 years from now. and I have no idea, what kinds of skills you're going to need at that time. We just can't predict like that, right? So this is another argument for, why we give you understanding and, experience with creative application, because that's what your life's going to be like after you get out of Duke, right? So if we give you understanding of ideas, if you see how those ideas develop, where those ideas come from, this algorithm works because of this strategy, this concept, these underlying sort of abstractions, then when you see something, it's not exactly that, but, not terribly different, you can take that understanding and adapt it appropriately and figure out then what you need to know as needed. Okay. So along these lines, on an exam, the ideas that you communicate in your solutions, the process of getting down to the answer, not whether you got the right numerical result. We're usually not so interested in that. But obviously we want you to have the right numerical result, right? But we need to see how you got there. Is your process complete? Is your process valid? Or did you make outrageous assumptions that don't apply and just ignored entire segments of a concern that happened to not affect the answer, but really could have, right? This is the kind of stuff that we're going to be grading on exams, right? So don't just use as you write solutions on the exams and likewise on the homeworks. Don't just write things down as a tool to keep it from having to do the whole problem in your head. That's not the point to the writing, right? So whether you get the right numerical result is not just what we want to know. I want to see your thinking. I want to get inside your head. Show me what you're thinking. This is what we're looking for. All right. Okay, likewise, again, exams are not just like the homework, right? We've talked about that previously. We want to see how can you deal with unfamiliar situations as a way of testing. Do you really understand what's going on? As opposed to just, memorizing. Okay, so there it is. Exams are not just like the homework. Every year, course evaluations, I read through the course evaluations, are usually very helpful. But there will always be at least one student that says the tests weren't fair. They were completely different from the homework. Well, yeah. Of course. They have to be, right? Okay. All right. And they're not completely different. They're, again, you can take the same ideas and solve the homework problem, solve the exam problems, but they're not going to be the same. This last thing is a very hand-wavy discussion. There's a misunderstanding, I think, common misunderstanding about how comprehension works. A lot of people think of it as a binary thing. I understand that. I don't understand that. Right? I like to think of comprehension as being more of a spectrum. And over time, as you're exposed to ideas, as you worked with ideas, your comprehension sort of continuously rises. Right? So the idea, in my opinion, anyway, I'm not an expert in neuroscience or this kind of stuff, but my perception is that students get this binary idea of comprehension because there's a bar they've been asked to get over. Right? This is where the test is, the high school test or the Calc 1 test or whatever. And as they study, their comprehension gets a little better, and eventually they get over the bar, right? Down here, can't do the problems. Up here, you can do the problems. Okay. So it seems like, oh, now I get it, right? You have these moments of where you feel like, oh, okay, now I'm totally good. I'm rock solid on this stuff. So y'all have been taking tests at certain levels for your entire, math careers. High school tests, a few college tests, and you've gotten kind of an idea of, in some sense, of where the level of expectation is, right? And that sets in your mind, sort of implicitly, this idea of what does it mean to understand something, right? It's on a continuum, but there's this, again, the experience of that's where you feel like, okay, now I understand, and so implicitly, the idea of understanding is set by your previous testing experiences. So you probably noticed in Math 212 that, the old high school bar, that's not where Math 212 set its bar. Math 212 sets its bar here. So students, common problem, they learn the material until they get up above where that old high school bar was. And they're like, oh, good, I get it now. And they come into the Math 212, the test is at this level right here. There's a gap, right? And the test doesn't go as well as they were hoping. Okay, so common problem. So what you have to do is get comfortable with this idea of how to raise your bar, how to demand more of yourself. As you study, as you learn the ideas more and more, you're going to get this feeling of, okay, I see how this works now. And you have to realize maybe that just means that now you've gotten your comprehension to the level that would have been good enough in a previous context. And you've got to realize that, the high school bar was here, Math 212's bar was here. Math 216's bar, a little higher than that, right? So, there's a higher level of expectation. It's a more advanced course. It's a more sophisticated course. So anyway, be aware of this phenomenon and study accordingly, right? Demand more of yourself. Demand that you understand it at a deeper level. Okay. I don't have any perfect answers to this question. How do you know when you've learned the material well enough? There's no standard units of comprehension. There's no scale for that, right? So this is all very hand-wavy and kind of intuitive or something. So the two things that I can give you, as you all know, as you might know, if you've clicked around on my webpage, all of my old midterm exams are right here. This is every midterm exam with solutions. With and without solutions that I've ever given in Math 216. You can see there's a lot of such old exams. So that's a lot of data points, right? Any old exam and its corresponding solution is an indication of what kind of question I think you should be able to handle and what level of sophistication, what level of communication clarity do I expect you to be able to give me the answers back in. So that's one, just kind of, again, by experience, a bunch of data points. That's one thing. Another thing that I think you can use, whatever it might be worth, is the following. This is just something to try, but I think you can use fear of public speaking as a tool to get inside of your own head. And it goes as follows. Let's suppose you're interested in whether or not you understand the checkerboard problem. Right? Okay. Ask yourself the following question. The question is not, can I do something kind of like a checkerboard problem? Ask yourself, could I come to the front of the class with 15 minutes and a dry erase marker, and could I give a 15-minute talk on the checkerboard problem and related issues? Right. Now, that I hope you would find that to be a scary prospect. Right? The dead silence in here seems to confirm that most of y'all would find that to be a scary prospect. So I think that's an indication that there's some things that you maybe haven't entirely 100% absorbed about that topic. Right? You understand it to a certain level, right? I'm sure everyone in here understands it at least to a certain level, but there's a lot of ideas that on some level you may be thinking, you're afraid, you're thinking about, if I'm up here and I'm explaining, someone's going to ask me what the deal is if this other case, and oh gosh, I haven't really figured that out yet, or I figured it out once, but then I got confused and I forgot, and I'm not sure if I understood it in the first place, one of those kind of deals. So the point is that fear of being caught in front of everybody, not knowing, right, is it's a way of that you can sort of be honest with yourself, forcing yourself to be honest with yourself about what do you really understand. And once you get to the point where you feel like, okay, I see this from every different point of view, I'm thoroughly comfortable with every aspect of it, I could crush such a talk, right? Then you really understand it very well. Does that make sense to everybody? Okay. Anyway, it's just a tool. It's just a tool for getting inside of your own head, sort of, understanding yourself. So it's, like I say, it's not a perfect answer to this question, but I think it's a reasonably good, it's better than nothing answer to the question. Okay, y'all already know this, right? Class has a reputation. Do be aware of this. This class does accelerate through the term. I think a lot of math classes do, but maybe not all of them. But certainly 212 and 216 have the feature that the last couple of weeks is harder than the first couple of weeks. Right? So there's going to be a lot more going on at the last of the course. Now, good news, you will be stronger mathematicians at the last part of this course. You're going to be so much stronger mathematicians that you will have the tools to be able to handle that harder course that it's going to be, right? But it remains, though, that the ideas that are discussed at the end of the course are significantly more challenging. So be ready for that. But do all your time management with this in mind, right? Don't fix the number of hours per week that you need to study for Math 216 based on, how the first couple of weeks goes. You want to leave yourself some slack. Okay. All right. Okay, so we already talked about the lecture recordings. I say might be made in here because, first of all, I won't be making the recordings during the flip portion. Other than this, again, procedural stuff. But also sometimes I have technical difficulties and the projector bulb burned out. Or somebody stole this HDMI cable and I don't have a replacement. Or a glitch in my computer. I don't know. This kind of stuff happens. It seems like it happens on average about once per semester. So the good news is, if that happens, I have recordings from previous terms, and I can hunt through my archives, and I can point you to a replacement recording that will be sort of equivalent. Okay. So I hope you'll use these recordings for studying throughout the term. I think it's great, like after any given class, think about what was it that you got, what was it you didn't get. Flip through the notes, look through the book, look for clarification on those points. And then once you feel like you're starting to maybe get those ideas a little bit more strongly, maybe listen to that portion of the recording and see if it doesn't just make more sense, right? After you've had a chance to solidify, the ideas going into those. I think that's got a lot of potential. I think it's a really good study technique, and I really encourage y'all to do that kind of thing. Likewise, it can be a great tool before midterm exams, right? So, some idea that's been plaguing you, you never really quite got the point of what is the purpose of reduced row echelon form. We're going to talk about that probably Wednesday. While you're doing the homework, sometimes a homework exercise is not terribly different from something that we explicitly talked about in class. Go back to the lecture recording. Listen to that discussion again. It might make the homework question go all the easier. Okay. So there's quizzes in this class. The attendance quizzes specifically are how I take attendance in the non-flipped, in the second half, if you will, of the course. And the way it works is there's going to be a quiz on Sakai. You got to bring your laptops to class, of course. And then the answer to the one question on the quiz will be the 3 or 5 digit number that's on the board, right? So it's a way, if you're here in class, you look, you see what the number is, you type it in, you get the points. Easy. If you're not in class, you can't see the number, and you can't get that quiz question. So anyway, it's a sort of a little hack that I use for taking attendance during the traditional portion of the course. Obviously, texting, emailing the code would be a clear Duke Community Standard violation. Don't take that. That is not worth it. It's really not worth it. I have caught students doing this. It's surprisingly easy to catch students doing that. So anyway, don't do that. For the first portion of the course, starting today, I'm not going to actually take attendance, but attendance is the only way that you'll be able to get access to the quiz. So there's going to be a quiz per my email. There's going to be a quiz starting in just a few minutes here. And I'm going to put the question up on the board. So the question for the quiz will not be on Sakai. Hang on a second. I forgot to set that up for today. Okay, the quiz for today is canceled. Sorry about that. Man. Okay, yeah. All right. So the very first lecture of the semester, I'm always kind of trying to get back into the swing of things, remembering how I did things. I forgot to make today's quiz, but normally you would just go into Sakai, and there's actually I don't really know what Sakai looks like on y'all's end, but I think there should be a button that says Tests and Quizzes. You click on that, it should be right there. You click, and the question will say, hey, what's the answer? And it will not give you any information about what the question is. I don't want students from their dorm rooms to be able to see what the question was, right? The question's going to be up here on this screen. So it's kind of, it's sort of a de facto way of seeing who's here and who isn't here. I guess from your dorm room, you could take a wild stab at it, right? But it's unlikely to work. So anyway, so I won't have an actual quiz today, but I will put the quiz question up there just so you can kind of see how this kind of thing feels. Anyway, altogether, those are going to count toward your grade. This TBD by instructor is, of course, no longer TBD. This is clearly enumerated on the class webpage, exactly how these quizzes are going to count. Grading system, here you go. Right? So the quizzes, your quiz adjustment will contribute. It'll add to your exam average by way of this formula right here. Not much of an influence, right? 0.2 is less than an incidental, but nevertheless, if you do a good job on the quizzes, right, there's an opportunity for that to make a positive impact on your exam score, your course score, right? But likewise, if you do a bad average, if your quiz performance is less than the class averages, right, then this could be negative. In which case, that might bring you down a little bit. No more than 0.2, of course. So, nevertheless, on incidentals, something that matters. Okay. Let's see here. Let's go back to this. Yeah. Okay. Very last thing I'll mention, and then we'll do the quiz. The study group email list. This may be a thoroughly outdated tool, but I would like for y'all to have access to a way to find a study group if you don't already have one. If you already have some friends in the class or people you want to study with, not necessarily the same thing, great, right? Go ahead and form your own groups. I think that's super. But if you don't have anyone that you'd like to study with, send me an email. I will add you to this list, and everyone on the list gets contact information for everyone else on the list. And only people on the list, right? So what this is a way to privately, without sort of putting your name up there publicly for all to see, if you would like to privately, find potential study partners, this is a way to do that. If you have another way of finding a study group, super, no problem. This is just something I can offer. Okay, how are we doing? Does anyone have any questions about any of this so far? Everybody happy? How do y'all feel about the grading system? Does anyone have any questions about the grading system? I want everyone to understand how this is going to work. I think it's pretty straightforward. Again, most of what we're talking about is it's going to be your exam average. So pretty much, we're going to look at your midterms. We're going to look at your final exam. Everything's going to be reported on the 4-point scale. Average them up. And mostly that's going to determine your course letter grade by this table, right? The only extra little bits is, of course, looking only at the exam average ignores homework. It ignores quizzes. It ignores other things not graded on the 4-point scale, right? So these adjustments here are just intended to sort of, recreate the impact that those things ought to have on your grades anyway. And by the way, this adjustment structure is pretty similar in effect to how they tend to adjust grades under the old system. Namely, people tend to have good homework averages, mostly, right? So nobody's going to stand out from the class by having this outstandingly high homework average. The maximum possible homework score is 50. The average homework score is about 45, right? So there's just not that much room to stand out. You can't really... Nobody gets a 90 on a homework, right? So on the other hand, while you can't sort of distinguish yourself in the positive direction, there is typically more space down at the bottom. So if you don't do the homework adjustment is going to hit you hard. Right? So what this is this provides a strong incentive to actually do the homework. But for those students who do the homework just, it doesn't really make that much of a difference as long as your score is kind of in the general vicinity of everyone else's. Likewise for attendance, right? Most people come to class because it counts and it's easy. All you got to do is show up. You got to do that anyway. The quizzes are a little bit in the middle. I mean, the quizzes are going to be challenging. I mean, I'll say non-trivial, right? So I'm not sure exactly what what the quiz average is, but it might be around 50%. So the quizzes that we'll do, we'll have one quiz per class meeting period for the first half of the course, and some of the questions are pretty straightforward and doable, and most of the students will get them. Some of the questions are a little harder. And so there's a range. I mean, sometimes 30% of the class gets the quiz question right. Sometimes 90% of the class gets the quiz question right. So there's a whole range there. So anyway, if you end up getting all the quiz questions, then there's room for you to distinguish yourself in the positive direction. Okay. All right. Okay. So let me take a pause. Zip it for a minute. Let somebody else get a word in edgewise. Any questions? Yes?
If we're absent for some reason for one or two of the quizzes, will it severely impact the 50%?
So if you are absent, it depends on why you're absent. If you send me a STINF and the corresponding follow up, and if it's an excused absence, then what I'll do is I'll just reduce your denominator. In other words, I'll scale, I'll sort of prorate. There's no makeup quizzes because that wouldn't be fair. You know what I mean? It's just I can't keep it secure, and I can't give you a different question because it would be either harder or easier. It just doesn't make any sense. But I can just change your denominator, and in effect, it's like that never happened on for you. Yeah. If you miss it, but it was not excused, then you just miss that point, and it's not such a big deal. It's just 1 point. But it does need to be excused. Yep. Anybody else? Likewise for attendance, by the way. Okay. All right. So let's do our little. So this is going to be a I guess it won't count. But let's look at the quiz question. If this had been a real quiz, I would ask you to have your laptops open. Typically, by the way, I'll do these quiz questions at the very start of class. So with that in mind, on Wednesday, come with your laptops, and at 1:40, which I think is when the class starts, right at 1:40, I'm going to say, okay, welcome back. Here's the quiz question, and the clock will be ticking. You'll have 5 minutes to answer one question. The question will be clearly on the board. By the way, you might have to scratch out a little bit of algebra, so come with a little paper and pencil, something that you can work with. And then you enter your answer on Sakai. Okay, so here's today's quiz question that I would have given you 5 minutes for had it counted. Let's see, how do I... okay, that's not right. Control plus, there we go. I will emphasize, so this question does not say for how many of these possible values of n can the array not be covered. The question is not asking about can the array be covered or not. The question is asking for which of these values of n, for how many of these values of n would the invariant argument allow you to conclude that the array cannot be covered. So this question is about in how many cases does the argument work, not in how many cases does the answer end up being one way or the other. So why don't I give you all a couple, 3 minutes to think about that, and then we will still have a couple, 3 minutes left, and so we'll talk about the answer. How about that? That'd be a good use of time. Yeah, okay, so it's great that y'all are chatting about this. Of course, this question here doesn't count. Just for the record, though, once we start counting the quizzes, discussions, wouldn't be appropriate. But feel free today, totally cool. Okay, so let's go ahead and talk about this. So, again, I've nothing to enter right now, but we have 3 minutes left of class, and let me just tell you what the answer is to this question. Well, actually, before that, how many people feel like they have an answer? How many people have what they think is a right answer? Everyone has an answer. Does everyone have a right answer? Okay, a lot of people. Good. Okay, let me talk through it. Now, let's look at the 8. We'll start with the 8 by 10 case. 8 by 10 looks, approximately like that. Here's an 8 by. I can do a better job drawing than that. So there's 8 by 8. There's an extra row for 9 and an extra row for 10. Okay, now remember we talked about in the example that we were given that all these diagonal entries will be the same color. Right? Well, that means that, I'll use orange, that one's a different color, and that this one is also the same color. Right? So what we have here then, in this case, when we remove opposite corners, we're removing 2 corners of the same color. When you remove 2 corners of the same color, you would need then for the invariant to be equal to either 2 or negative 2, but it can't. The invariant's always 0. Right? So this gives us a contradiction. This 8 by 10 case, you cannot cover it with the dominoes because covering it with the dominoes would require 0 to be 2. Everybody see how that worked? It's morally equivalent to the thing that we talked about in the pre-lecture. Now, let's consider now 8 by 11. If it's 8 by 11, there is another column. That corner then is going to be the opposite color. Now look what's happening. Now we're removing 2 corners of opposite color. That means that if we were to cover this with dominoes, it would require for the invariant to equal to 0. Oh, well, the invariant has to equal to 0. I mean, if the invariant is known to be 0, and if we have an argument that shows that, well, we need the invariant to equal to 0, well, no problem. There's no contradiction there. The idea that we would have the audacity to suggest the invariant might be 0, yeah, it is 0. So no contradiction. So the argument fails. Right? So let's, I'm going to put some check marks over here to represent the argument. So for 8 by 10, the argument succeeds. For 8 by 11, the argument fails. And you can sort of imagine how this process continues as you add more and more columns. Those bottom right corners keep changing. One color, other color, one color, other color. So check, X. et cetera, et cetera. And as it turns out, the answer to the question is then between 10 and 20 inclusive, how many of those numbers are even? And so the answer is 6. Everybody on board? Right? So notice that what this question did is it asked you to take, pretty much the ideas that we talked about in the pre-lecture, but you have to apply them a little bit differently. You have to think creatively about them. So, good example in that sense. See y'all Wednesday.